All right, everyone. Welcome back to the channel. This is Mr. Tueller coming at you live from my basement in Eagle Mountain, Utah. I'm just so excited for this lesson, our first lesson of 5.1, our first lesson onto YouTube, onto the internet. It's just a great time. Guys, we got 5.1 operations and composition of functions. Okay, this is going to be a quick one for you guys, and then you'll be let free to work on your homework assignment. Make sure you have your your book open to page 82, and we will begin. Addition, subtraction, multiplication, division of different functions. It has weird notation, but we've done this stuff before. So look over here. We're going to let, that's a bad color. Let's pick pink. We're going to let f of x be the equation 3x, and we're going to let g of x be 2x minus 4. Okay, so then we have this notation over here. Addition. This is read f plus g of x. It's a shorter way to say we want you to add the f equation to the g equation. So over here, f of g of x would be the f equation coming from right here and the g of x equation coming right there. They add together to give you 5x minus 4. Just combining some like terms there. Subtraction, very similar here. We've got f minus g of x. We're going to take the f of x equation and subtract the g of x equation. So right here it is again, and there's, the 3x coming in for f of x, and the g of x, the 2x minus 4 coming in right there. We subtract them, we combine these two like terms, and we get x. And this negative distributes to that 4, x plus 4. Simple combining like terms. Okay, multiplication. F times g of x. Take the f equation and multiply it to the g equation. So I give you the f equation, 3x, multiply it to 2x minus 4. Distribute it in 6x squared minus 12x. Okay. Division, f divided by g of x. In other words, take the f equation and put it over the g equation. We take the f equation, put it over the g equation. We look for anything that can simplify. I would tell you guys to factor. So I would actually go even more simple and call this one 3x over 2x. 2 parentheses x minus 2. I took out a GCF on bottom just to verify that nothing simplifies right there out front. But it doesn't, and that's our answer. Now, this is telling us right here, what I'm circling in purple, our excluded value, or what x cannot equal. A domain restriction, a point of discontinuity, a vertical asymptote. Okay? All right. Let's move on to now composition. This up here was mostly just operations of different functions and the weird notation we use to write them. But down here we got composition. Now this is where it gets a little bit weird. Look, this is an open circle right here. This is composition g of f of x. It looks very similar right here. This is f dot g of x. That means multiplication. But down here, we have an open circle. So, just so you know, f open circle g, fog x, is very different than this. Very different than that, okay? This is what composition means. This means take whatever equation we're talking about here, f of x, and plug the entire equation in to g. Okay, so, you know what? Let's flip the page here. flip the page. I'll give you a second to flip the page. Let's talk about this in a minute, actually. Let's do some operations on our own. I should have waited to show you guys this composition stuff. We'll get back to composition in just a second. Let's do this stuff right here on the next page. Now, let me think. 7th period. Christian, stop talking. Okay. Let's continue. Find f plus g of x, f minus g of x, f times g of x, and f divided by g of x. And I'm giving you both f of x and g of x. Okay. First, f plus g of x. We take the f equation and we add the g of x equation. Now the reason why I'm putting the g of x equation in parentheses right here, in these green parentheses, is because it's a two-term equation, a two-term function. Okay, we want to make sure that we don't miss anything when we're multiplying or dividing and things like that. I could put parentheses around this, but because it's a single term, I don't really need to. Now, because this is addition, I can actually just drop these parentheses. We're going to combine like terms, negative 2x plus 5. That would be f plus g of x. Okay, now I should have written way smaller, but we'll come over here and do f minus g of x. So like I wrote the f equation, this is f of x, this is g of x, and I'm subtracting the two. Okay, I'm subtracting the two. Now this is where the parentheses are important because I'm subtracting, I'm going to distribute the negative. Distribute the negative, combine like terms. Nope, that's a minus. And that is f minus g of x. Okay. Eighth period. Connor, put that kendama away. Let's multiply. F of x times g of x. That's what we're doing here. F of x is 2x. G of x is negative 4x plus 5. Okay? Multiply this in. Negative 8x squared plus 10x. Those are the two equations multiplied together. Okay? And last but not least, let's divide. Hey, just so you know, guys, we're not doing this equation right here. For some reason, it didn't even give me the g of x, so we can't even do anything with it. So we'll use its space. F of x divided by g of x. 2x over negative 4x plus 5. Now, most of the time, we love division the most. You can't even simplify that. There's no GCF on bottom. Now, this is a mistake. We cannot simplify this because we're adding a 5 right there. So this is going to be our answer of the division question. Okay. Let's get into composition. Like I was saying, when you have the open circle, we're talking composition. That means put this equation in for x in the previous equation written. So this means, right here, take g and plug the entire equation in for f. Take g and plug the entire equation in for f. So we're going to take g and plug it into f. So what I'm doing here, x plus 5 goes in for x right there. And that's what I've written right there. We simplify. And this is f of g of x simplified. Okay, now g of f of x is different. Take the f equation and plug it into g. I'm taking this whole equation right here and plugging it in for x. We don't even need those parentheses. G of f of x is 2x plus 5. Now this wants me to state the domain and range of each of these functions. Okay, this is not very difficult. We just need to know this is a linear. Linears have a domain that reaches all possible x values. They also have a range that reaches all possible y values. All linears. If you can picture a linear graph, they look like that. They will cover all x values, all y values. This one is also linear. The domain, negative infinity to infinity. The range, negative infinity to infinity. Now I know I just went fast with that. But we should know by now that linear equations have a domain and range of negative infinity to infinity. Okay, I'll leave that one there for a second. Let's do f. Well, let's put g into f. So f of g of x. We're putting g into x. So look, I took this equation right here, x minus 6, and it got plugged into x right there and x right there. Now we simplify. So I distributed this, and now I need to distribute this. Combine like terms. Ooh, those cancel. Almost there. Okay, so we get x squared minus 6x minus 2. That's if I plugged in g into f. Plug g into f. Now, this right here is a quadratic. What is the domain of all quadratics? Negative infinity to infinity. Domain always. Okay, now we need to think about what the range would be. What is the range of this equation? Well, maybe we need to take it over to Desmos. Let's visualize this. X squared minus 6x minus 2. This guy reaches all the way down to negative 11. I'm okay if you use Desmos to find the range of these functions. Okay? Before, we could have plugged in those linears. But if you know that linears have a range and domain from negative infinity to infinity, like we were doing up here or back here, then you can save yourself some time. But I'm okay if you want to just plug them into Desmos and find yourself the range from negative 11 to infinity, and that should be a bracket. Okay, let's move on to plugging in some numbers, and then we're going to be done. Okay, this one right here is it's another way to write composition. If we look back to this previous page, a lot of the times we use this O notation with the O right there. It means the same thing as just putting F in to G. See, look, I was saying take F, put it into G. This notation right here is also used. Put F into G. But what if I put in a number for X? I'm now wanting you to evaluate these compositions. So this is what I'm going to do. We just work from the inside out. We're going to put the number 1 into the G function. Plug in a 1 for G. Five. Now we take the number 5 and we plug it in for F. So F is right there. And the answer is 15. Okay, did you see that process? Let's do a different one. I'll leave that one up. Work from the inside out. Take first a -1, and plug it in for F. So here's the F equation. I'm giving it to you in the instructions. 3 times -1. That gives me -3. Okay, now I take that -3 and I'm going to plug it into which equation? A G. So this whole thing equals -3. Now I'm plugging -3 into G. It equals 1. So the notation we should be saying is G of F of X. No, not X. Whoa. Not X. -1 is the number we're plugging in. Equals 1. Okay. Let's put a -3 into H, and then take whatever number that gives us and put it into G. So -3 goes into H. -3 squared minus 1. That gives me 9 minus 1, 8. 8 now goes in to G. 8 plus 4 is 12. We should be writing it like this, though. G of H of -3 equals 12. Okay, if you are enjoying this video, don't forget to hit that like button. If you've made it this far, don't forget to subscribe. I really appreciate it. I couldn't be doing this without you guys. So thank you. And if you really want to, hit that bell so you don't miss another video. We're going to end off with 2 more. Here we go. This one is interesting. Work your way from the inside to the out. Or in other words, it's kind of like moving from right to left. -2 into H. Whatever you get, put it into G. Whatever you get, put it into F. So let's put a -2 into H. -2 squared minus 1. That is 4 minus 1. And 4 minus 1 is 3. So now the number 3 goes into G. I should put it like this, because if we plug a -2 into H, plug in a -3, sorry, not negative, plug a 3 into G. 3 plus 4, what do we get? 7. So now we take the 7 and we put it into F. 21. 21. Okay. You know what? I said I was going to do one more. You guys go ahead and try number 9 while I get you a motivational sticker to cap off this video. I'm so happy you guys made it this far. If you liked the video again, don't forget to subscribe, hit that bell, smash that like button. Guys, I can't wait to get back to see you guys. We're such good friends. Enjoy the rest of your day working on the homework assignment, and catch another video on Brendan Tueller YouTube channel next time.